Good morning, everyone. Now we are going to talk about Johannes Kepler. Johannes Kepler was a sickly child and his parents were poor, but his intelligence allowed him to have scholarship in University of Tübingen to study for the Lutheran ministry. In this university, he was introduced to the ideas of Copernicus and he delighted in them. In 1596, when he was a teacher in Graz, he wrote the Mysterium Cosmographicum, an astronomy book that, if translated, it means the secrets of the world. When he was a student, he studied Nicolaus Copernicus' theories of planetary ordering. In 1600, Kepler went to Prague to work for Tycho Brahe, who is a Danish astronomer. His main project there was to investigate the orbit of Mars. In the early 1600s, he then proposed three laws of planetary motion and was able to summarize the data that were carefully collected by his mentor, who is Tycho Brahe. Kepler's three laws of planetary motion. These are the laws that describe the motion of the planets in the solar system. First one is the law of ellipses. Next is the law of equal areas, and under it are rotation and revolution of the Earth. And lastly is the law of harmonies, the law of ellipses. This is also known as Kepler's first law. An ellipse is a special curve in which the sum of the distances from every point on the curve to two other points is a constant. This law simply means that all planets move around the Sun in elliptical orbits, having the Sun as one of the foci. The next law, which is law of equal areas, also known as Kepler's second law, wherein it describes the speed of the planets when moving in the orbit around the Sun. He also said that the speed at which any planet moves through space is constantly changing, and a planet moves fastest when it is closest to the Sun and slowest when it is furthest from the Sun. However, an issue was addressed by Newton when Kepler failed to explain why planets maintain their position in their respective orbit. The rotation of the Earth. It is the spinning of the Earth around its axis. The axis has an angle of 23.5 degrees and is perpendicular to the place of Earth's orbit, meaning the Earth is tilted on its axis, and because of this tilt, the northern and southern hemispheres lean in a direction away from the Sun. The rotation of the Earth was divided into two: the lit up half, which gives rise to the day, and dark half, which gives rise to the night. Revolution of the Earth. It is the movement of the Earth around the Sun in a fixed path. It revolves from west to east. The Earth then completed one revolution around the Sun in 1 year, or 365.242 days to be exact. The revolution speed of the Earth is 30 km per second negative 1 or minus 1. The Earth is closest to the Sun at its perihelion, wherein the orbital velocity increases, and farthest from the Sun at its aphelion, making the orbital velocity decrease. Like the Earth's orbit around the Sun, the Moon's path around the Earth is elliptical. The point in the Moon's orbit that is closest to the Earth is called the perigee, and the point farthest from the Earth is known as the apogee. The term are also sometimes used interchangeably with the Earth's perihelion and aphelion. Lastly, the law of harmonies. This is also known as Kepler's third law. Unlike Kepler's first and second laws that describe the motion characteristic of a single planet, the third law makes a comparison between the motion characteristics of different planets. The comparison being made is that the ratio of the squares of the periods to the cubes of their average distances from the Sun is the same for every one of the planets. As an illustration, take a look at this table. You can see that when you compare the t-square over r cube of the Earth and Mars, they are the same. In fact, if the same t-square or over r cube ratio is computed for the other planets, it can be found that this ratio is nearly the same value for all the planets. Take note that T means the period and R is the distance. To further clarify these three laws, let's watch a video.
So planetary motion are laws describing the motions of the planets in the solar system. They were derived by the German astronomer Johannes Kepler. There are three laws of planetary motion. Let us talk about them one by one. Kepler's first law of planetary motion, sometimes referred to as the laws of ellipses, can be stated as all planets move about the Sun in elliptical orbits, having the Sun as one of the foci. This means that planets are orbiting the Sun in a path described as an ellipse. This is a picture of an ellipse. Suppose this ellipse is where the planet Earth moves. The Earth moves along the ellipse around the Sun. The Sun is located at either one of foci of the ellipse. Now let us move on to the second law. Kepler's second law of planetary motion, sometimes referred to as the law of equal areas, can be stated as a radius vector joining any planet to the Sun sweeps out equal areas in equal lengths of time. The second law describes the speed at which any given planet will move while orbiting the Sun. Note that when a planet is close to the Sun, it moves fast, but when a planet is far from the Sun, it moves slowly. So if we draw an imaginary line of the movement of the planet and the Sun for every month of the year, we can see that when the planet is close to the Sun, it will form a wide but short triangle, and when the planet is far from the Sun, it will form a thin but long triangle. The Earth would have to adjust its movements in order to match the imaginary area. Did you know that the knowledge of Kepler's second law has proved the importance of Newton's law of gravitation? Newton showed that the motion of bodies subject to central gravitational force does not always follow the elliptical orbits as specified by the first law of Kepler, but instead, planets or other heavenly bodies can take paths defined by other open conic curves. Amazing, right? Now let us move on to the Kepler's planetary motion, sometimes referred to as the law of harmonies, can be stated as the squares of the sidereal periods of the planets are directly proportional to the cubes of their mean distances from the Sun. It compares the orbital period and radius of orbit of a planet to those of other planets. It is the ratio of the squares of the periods to the cubes of their average distances from the Sun is the same for every one of the planets. The comparison of each planet can be shown in this illustration. Now, what does that mean? Kepler's third law means how long a planet takes to go around the Sun, which is its period, is related to the planet's mean distance from the Sun. That is, the square of the period divided by the cube of the mean distance is equal to a constant. And for every planet, no matter what its period or distance, t squared over r cubed is the same number. And that's it.
To continue, it was stated that Kepler's effort to explain the underlying reasons for such motions are no longer accepted. Nonetheless, the actual laws themselves are still considered an accurate description of the motion of any planet and any satellite. Kepler died in Regensburg after a short illness. He was staying in the city on his way to collect some money owing to him in a connection with the Rudolphine tables. He was buried in the local church, but this was destroyed in the course of the 30 Years' War and nothing remains of the tomb. That is all, and thank you for listening.